Alright, this video is about angle relationships, especially with the unit circle and trig. Okay, first we need to remember what we talked about yesterday, degrees versus radians. So here's your grid. You know 0 degrees, 90 degrees, 180, 270. Well, in radians, remember we said that at 180 it's pi. So at 90 that means it's half a pi. At 270 that's pi, 1.5 pi, so that's 3 pi over 2. And at 360 it's 2 pi. And remember, as number values, that's 1.57 radians, 3.14 radians, 4.71 radians, and 2 pi is 6.28 radians. Okay, so hopefully that makes sense. You recall those values. Okay, so you're going to have to convert degrees to radians. So you're going to simply multiply the degree, whatever degree, times pi over 180, and reduce it, and that is what it will be in radians. If you're going from radians to degrees, you multiply by the reverse, 180 over pi. And you'll see how this works in some examples. Alright, so first, this first one, it says just to graph 11 pi over 3. Alright, let's think about this. In my graph, I know that pi is here. 11 pi over 3. That means, if I convert this to a mixed number, let's think about this. 3 goes into 11 3 times, with 2 left over. So 3 2/3 of a pi. Alright, so initial side of my angle is always here, remember this? Okay, and I need to go 3 2/3 of a pi. So if I go, here's 1 pi, here's 2 pi's, here's 3 pi's, and I need to go 2/3 of the way. So that means I'm going to land right here, and this is what 11 pi over 3 would look like graphed. Number 2, I need to graph negative 2/3 of a pi. Alright, so remember your negative angles, 0 and then negative pi over 2, down here. So negative 2/3 of a pi. Initial side is always here. If I go 2/3 of a pi, this is half a pi, negative half a pi. 2/3 is more than that, so I would go about right in here. But I have to show my arrow of direction, right? Show my arrows to show that it's a negative angle. It would look something like that, all right? Then lastly, a conversion. Convert negative 2 pi over 3 to degrees. All right, in order to convert it to degrees, from radians to degrees, we said that you have to multiply by 180 over pi. Okay, so I'm going to multiply. Look, I can cancel the pi times pi, can reduce 180 by 3, and that gives me 60. And then multiply straight across, I get a negative 120 degrees. That would be my answer. Okay, so follow those conversions you got on the previous slide to know radians to degrees or degrees to radians. But it works the same similarly almost every time. Okay, the next relationship is coterminal angles. Okay, look at this picture. Here's an angle, the blue angle. Look, that's 120 degrees. But then there's an angle in the negative direction that matches it. It's negative 240. But they are the same angle. They look exactly the same if you didn't have the arrows. So those are called coterminal angles. They create the full circle, if you will. So the definition says if two angles have the same initial side and terminal sides, they are called coterminal. There are infinitely many coterminal angles for any given theta. All right, that just means you can go around the circle multiple times, and there's going to be a coterminal angle for it because it just depends on the direction you're reading as for the name of that same angle. All right, so you're going to have to find two coterminal angles, a positive one and a negative one. If you're finding the positive one, if it's in degrees, you simply add 360. If it's in radians, you add 2 pi. To find the negative coterminal, you subtract 360 or subtract 2 pi. Just depends on the direction you want. Alright, so find the positive and negative coterminal angles for pi over 6. Well, let's think about pi over 6 is less than half a pi. So that's down here, right? If I'm looking at my positive angle, there's pi over 6. To get my positive coterminal angle, I'm going to add 2 pi. Well, remember with adding fractions, you always have to have a common denominator. So my common denominator is a 6. So I multiply 2 times 6, I get 12. Oops, that's a plus sign. I'm sorry. Pi over 6, which gives me 13 pi over 6. So that's 2 1/6 of a pi. So in the positive direction, I would just go all the way around one full circle and come back, and that's the same angle. It's the same angle. To find the negative, I would subtract 2 pi, same common denominator, minus 12 pi this time, gives me a negative 11 pi over 6. So if I go in the direction, the opposite direction, let me go this way, that is a negative 11 pi over 6. Alright, so it's the same angle, has the same initial and terminal end, it just depends on the direction. So there's my two answers, a positive and a negative coterminal angle. Alright, the third relationship is complementary angles. You should remember this from your geometry days. Two angles that add up to 90 degrees. Or now with radians, two angles that add up to pi over 2. Alright, so I'm not worried so much about the degrees because you should be able to subtract from 90 without a problem. Let's focus on the radians. Okay, so find the complement of pi over 6. So what I'm going to do is I'm going to subtract pi over 2 minus pi over 6. See what I need. Okay, common denominators are essential. So my common denominator is going to be a 6 here. So that means I have to multiply this first one by 3 over 3. So I get 3 pi over 6 minus pi over 6. Means my complement then is 2 pi over 6, which reduces to pi over 3. Okay, so there's the complement. There's what's going to make that angle reach pi over 2. 4. Okay, so pi over 2 minus 3 pi over 4. Again, you got to get a common denominator. This time it's a 4. Yeah. Okay, so common denominator is going to be a 4, so I got to multiply by 2 over 2. So it gives me 2 pi over 4 minus 3 pi over 4, which gives me a negative pi over 4. Okay, your complements cannot be negative, which means that 3 pi over 4, think about it, where's that graphically? It's over here, right? Well, that's greater than pi over 2. Here's pi over 2. That's greater than that, so there is no complement. You would just say there's none. Okay, there's no complement at all. So that sometimes they'll ask you that, but think about where it is on the graph and you'll understand why it came out negative. Okay, the last one is supplementary angles. So back in geometry days, you learned that two angles that add up to 180 are called supplementary angles. So now we throw in the radians, pi. Pi and 180 are interchangeable, remember? So to find the supplement of pi over 6, well, I just take pi and I'm going to subtract pi over 6. Well, common denominator is going to be a 6, so I have 6 pi over 6 minus pi over 6 gives me 5 pi over 6. So there's my supplement to it. Alright, so keep in mind, like if they give you something that's greater than 1 pi, then you know there's no supplement. Okay, it's already greater than pi. Similarly to what we did in complementary angles a while ago. Alright, for the whisk, you're going to find a positive coterminal angle for 56 degrees, easy. And for the number 9, you're going to find the complement of 2 pi over 5. Okay, this one may be hard to type in the whisk because of the pi, so just have this answer ready to go in class, but you can definitely put your answer in for number 8. Okay, good luck and see you in class.